Hello and welcome to the continued coverage of the walkthrough series. And in this episode, we are looking at the summer 2025 variant 4.1 practical paper. Let's go ahead and jump right in and look at number one. So we have been supplied with following source files. These are the source files that we've been supplied with. And if I expand my file explorer right here, you actually see that I've put the files in here, including the evidence document. Then make sure that, of course, these are the instructions for candidates and the format with which you are going to save your evidence document. So 7 source files are going to be used for question 2. So we are not going to be using the source files for this particular question, but you see them in the next episode for question 2, rather in the next video for question 2. So number one here says that a program stores positive integers in a circular queue. The queue is stored as a global 1D array of 20 integers with the identifier q. Each index is initialized with the data -1. The global variable head pointer initialized to -1 points to the first element in the queue. So goes for the tail pointer, same position as the head pointer, as well as the number of items as well. So our task is to write program code that is going to declare and initialize queue, head pointer, tail pointer, and number of items. And in here, right here, we've been told that these are global variables. So let's go ahead and look at how you can implement that in Java. So number one, item A, we are going to perform the variable declarations and initializations. So you see that our variable declarations are going on inside of this particular question 1J 2025 class as it were. So from lines 5 up to lines 8, we are declaring those variables and initializing them as instructed in the question paper. So for this, you can go ahead and copy this code and paste it inside of your evidence document, and you'll get 2 marks for that. Then moving on to the next question. Question B, we are instructed to create code for the function code in Q, and it's going to do the following things. So it's going to take an integer as a parameter, checks if the queue is full, returns false if the queue is full. So essentially, we are not going to be able to enqueue any items if the queue is full. So that's why we are going to return false. Otherwise, if we are unable to enqueue anything, then we should return true. Then it's going to store the parameter in the next position in the queue and returns true if the queue is not full. Then it's going to update the appropriate pointers and number of items, or rather number items as it were. So let's go ahead and look at the implementation going on here in Java. Number B, let me scroll all the way down to line 22. That's where I have my implementation for the enqueue method. So you see that our method header is going to imply that we are going to return a Boolean value, and we are taking an integer argument or parameter, and we are naming it value. So the first thing that we are going to do is to satisfy this condition where it says here that we should return false if the queue is full. So that's what we want to do first. So that's why you see from lines 24 to lines 26, we have that code block that's essentially going to return true if number of items is equal to the length of the queue, as it were. Then we are also going to move ahead and set the head pointer to 0. After which then we are going to, that is to say, if the head pointer is -1, it means that we have nothing in the queue as it were. Essentially our queue is empty. So we are going to set head pointer to 0, because after that point, after that action, we are actually going to have in the first element in our queue as it were. So on lines 30 to 35, we have the code block. Rather, we have lines 30 to 34, we have the statements that are essentially going to allow us to represent or to push our element into the queue as it were. So remember that this is a circular queue, and the way we are doing it is to ensure that if the tail pointer is going to be pointing at the last position in the queue, we want it to move back to the -1 as it were, or to the starting position as it were, because this is a circular queue. You can check out my other videos. I have an animation for how a circular queue works. I'm not going to go into detail for the implementation here, but I'm just going to explain briefly how it works. Then we are moving we need to perform that action where it says that we are going to store the parameter in the next position in the queue. So that's what we are doing on line 32. Then line 33, we are simply incrementing the number of items because we've added a new item into our queue, so we need to increment it by 1. Then we finally return true on line 34, and that is the implementation for the enqueue method. And for this implementation, you will get 6 marks, as it were. Then, of course, you would go ahead and copy this code and paste it inside of your evidence document. Moving on to part C. The main program attempts to store each of the integers 1 to 25 inclusive, that is, in the queue in ascending numerical order using enqueue. It's going to output the integer that was passed to enqueue and successful if it was stored in the queue, or unsuccessful if it was not stored in the queue. For example, if the integer 5 is passed to enqueue and is stored in the queue, the output will be 5 successful. If the integer 23 is passed to enqueue and is not stored in the queue, the output will be 23 unsuccessful. So we are supposed to write program code for the main program. For this, we are going to get 3 marks. So let's actually go ahead and look at the implementation here. So let me scroll all the way up, because that's where I have my main method, starting on lines 10 to lines 20, as it were. So what we are going to do is, since we know that from the question, it says that we are going to store the integers in ascending order. So what we can simply do is to use a for loop, a count controlled loop, as it were, so that we can count from 1 to 25 inclusive. And essentially what we want to do is we want to have a boolean. So the way I did it here was to for enqueue. Remember, enqueue is going to return a boolean true or false, is it? So if I were able to enqueue, let's say initially the value is 1, right? It's going to return true, and I'm going to store true inside of result. And this is going to happen 25 times, is it? So for each of these times, I'm actually going to be able to check to see if I were able to enqueue a particular element. Then if the result is true, I'm going to output successful, otherwise I'm going to output unsuccessful. So I have this strange in syntax that you're seeing here on line 14. This is called the ternary operator. I think I might have covered this one in my Java series. I might have covered this one, but if I haven't, let me just quickly explain how it works. So it has 3 parts. That's why it's called the ternary operator. So the first part is a Boolean condition. The second part is the action that you would want to be performed if the condition is true. Then the other part right here is the condition that you would want to be performed if the Boolean result is false. So suppose that the Boolean result is false, is true, rather let's start with true. So if I were able to enqueue 1 right here, then I'm going to output successful. Otherwise, I'm going to, if I were not able to enqueue 1, then it means the result is going to hold a value of false, and it's going to jump and perform this particular action here. So that's the ternary operator right there. So it makes it easier for us to type, rather to test conditions such as these ones, where we have 2 branches of execution that rely on a Boolean condition, as it were. So this would be what you need to write for the implementation in order for you to get the 3 marks indicated here. So let's move on to part D. The function dq returns -1 if the queue is empty. If the queue is not empty, the function returns the next item in the queue, updates the appropriate pointers, and updates number items. Write program code for dq, and for this we are going to get 6 marks. So let's actually go ahead and look at the implementation I have going on here for dq on lines 38 to 52. So from the description that we have going on here, it says here that it returns -1 if the queue is empty. So you know that dq is going to have a return type of integer. So that's why you see we have declared it as an integer dq, the function here that is on line 38 there. Then if the queue is not empty, the function returns the next item in the queue. So essentially our queue is going to be storing integers, so we would be able to return the item. That's what we're doing on line 51 there. But before we do that, we actually need to do a couple of things. So what we are doing on line 39, we are checking to see if the number of items is 0. So essentially, if number of items is 0, it simply means that we have nothing in the queue. So we have satisfied the first condition, where it says here that we should return -1 if the queue is empty. Then if the queue is not empty, we need to take that item that is being pointed at by the head pointer and store it inside of the variable item. Then the next thing that we need to do is to set the head pointer, or rather to set the position where we took that element to -1. Then the next thing that we need to do, so since this is a circular queue, you need to remember that this is a circular queue. We are going to move the head pointer to the next position in a circular manner, as it were. Again, you can always make a reference to my circular queue animation. It's on my channel. You can check out my other videos on the channel so that you can get an animation of how a circular queue works. Then we are decrementing the number of items because we've removed an item from the list, as it were. Then if the number of items is 0, after decrementing number of items, right, if we decrement it so that it's now 0, we are simply going to set the head pointer to -1 and the tail pointer to -1. This is where they say that you should update the appropriate pointers right here. Right? So that's what we are doing there. We are taking care of that aspect right there. Then obviously we are concluding by returning the item as it were. Then for that implementation, you are going to copy this code and paste it inside of your evidence document. Then for this implementation, you are going to get 6 marks, as it were. Then let's look at item E. Write program code to extend the main program to call DQ twice and output the return value each time. So for this one, let's go ahead, let's scroll all the way up to the main method right here. And you see that I'm calling DQ on lines 18 and 19. So I'm calling it twice. And I'm going to DQ the elements as per the requirements here in the question. Then E item 2, we are supposed to test our program and take a screenshot of the output. So let's go ahead and run our program and see if it works. So click on run, then you're actually going to see that this is the output from the program, as it were. So you see that we were able to successfully enqueue 1 all the way up to 25. Then we've dequeued 1 and dequeued 2. So that does it for this question and also for this episode. So yeah, I will see you in the next one.